Hi, now we'll deal with something quite important, memory state diagrams. Now the objective here is to learn how to draw memory state diagrams to aid in tracing a Java program when it's running, what happens, what gets stored in this variable, what gets stored in the second variable. Okay, when you use the equal sign to assign A equals to B, what happens? Now, we are going to handle primitive type variables, object reference type variables, and arrays. Now, why is this important? If you have attended, now some textbooks won't even talk about memory state diagrams. Some Java courses you have attended may not even talk about memory state diagrams, or probably give you a something quite brief. Now, it is important to understand how to draw memory state diagrams because you will understand how values are assigned to variables in Java. One important note here is that there is no standardized way. There's no standardized way to draw memory state diagrams. Now, the drawings which you will see in this video and in subsequent videos are it's just one way of doing things. This is not UML. UML stands for Unified Modeling Language, whereby in a UML class diagram, a class has to be a rectangle, the class name has to be at the top, and stuff like that. Remember that there is no standard way to draw memory state diagrams. So be very careful when you say a diagram is wrong. Uh, what is important is that your diagram needs to be clear, right? Just some points, refresher points before we even start on memory state diagrams. Then there are two main types of variables. Variables in Java can be distinguished in this way. It can be a primitive type, also known as a simple type, or an object ref type. Now, there are 8 primitive types in Java: byte, short, int, long, float, double, boolean, and char. So if I declare a variable using one of these 8 types, this is actually a primitive type variable. Now, all other types will be considered object reference type variables. For example, if I declare a variable like that, a type is string. S is an object reference type variable. Why is it called this way? Because S will store the address of a string object. The value of S is either null or the address of a string object. That's why they are called object reference types. Now, another important point is that method calling in Java, when you call a method in Java, Java does what we call a pass by value. All right, when a method takes in parameters, okay, what will be passed over will be the value of something. We'll see examples later. This may not this term passed by value may not be important to you if you have never been exposed to C or C++, because in C or C++, when you call a method, you can either pass by value or you can pass by reference, and things get very complex. Pass by reference. Java, very simple. Everything, when you call a method, everything will be passed by value. Now, what is important here is if you are passing over a primitive type, the value which is being passed over to a method will be the actual value stored in the boolean or the int. Now, the value of an object reference type is actually an address of an object or null. Okay, an object reference type you can store null in it. You can't store null into a primitive type variable. Again, we'll revisit this concept later when we look at some memory state diagrams. Now, there's another way to categorize variables. In Java, a variable can be a local or can be non-local. Now, a local variable is one which is declared in a method. All right, local variables need to be initialized before you use it, or else you can't even compile the program. Now, attributes do not need to be initialized, although it's a good idea to do so, because they'll always be given default or initial values. Okay, 0, null, or false. But local variables will not be given default values, and you must explicitly give them a value before you use it. Now, local variables will be discarded once the method returns. Okay, so of course, when you discard the local variable, the corresponding value will also be discarded. You see this when you draw the memory state diagram. You call a method, we return from method, all the local variables used in the method will be thrown away. Now, if you look at a method signature, this method is called do something, and it takes in, it has two parameters. It takes in an int and a string. X and Y in this case are also considered local variables. Now they are not declared in the method per se. In this case, Boolean, oops, not very clear. If there's a statement here, Boolean B. Now B is a local variable because B is declared in the method body. In this case, X and Y are not really declared in the method body, but they are considered local variables. So when do something returns, X and Y are also thrown away. So this is the part 1 of the 5 videos for memory state diagrams. Alright, in part 2, we will cover primitive types and examples. In part 3, we'll cover object reference types with examples. In part 4, we talk about array lists, and we'll end with an example, a fuller example, okay, of how to draw a memory state diagram. So in the next video, we'll move on to primitive types, the easier ones.